power in amplitude modulation. We have proved that the amplitude modulation voltage is equals to EC sin omega ct plus MA EC divided by 2 cos omega c minus omega m t minus MA EC divided by 2 into cos omega c plus omega m t. This is the mathematical equation of wave in amplitude modulated wave. This is the amplitude modulated wave. This equation is derived in earlier class. Now we will discuss the power in amplitude modulation. There are three terms. This is called carrier wave, and this called sideband, and this also called a sideband wave. First of all, we should know what is the power in a wave. So power can be calculated as power is equals to Vrms by R. This is the equation. Using this equation, we can calculate the power. First of all, we should calculate the power of the carrier. So number one, power of the carrier wave is given by Pc, can be written as, this is the amplitude. So if I convert it into Vrms, then it will be amplitude divided by root 2, and this is the square, and this is the Vrms, okay, divided by R. So it can be written as EC square divided by 2R. So this is the power in amplitude modulation, power of the carrier. Now this is one sideband and this is another sideband. So total power in sideband, so number 2 is total power in sideband can be written as PSB is equals to, this is the amplitude, so it can be written as amplitude EC divided by, this is amplitude, in divided by root 2. So it will be the Vrms, and this is the square. So this value divided by root 2 divided by R. Similarly, it can be written as MA EC 2 root 2 divided by R. So it will be MA square EC squared by 8R, and it will be MA square EC squared by 8R. So this, if I add this, so it will be MA square EC squared by 4R. So this is the equation of power of the sideband in this amplitude modulated wave. Now we will calculate the total power in amplitude modulated wave. Amplitude modulated wave, then it is the PT. So PT can be written as PC plus P sideband, PSB. So if I put this value, it will be, this is EC square divided by 2R plus it will be MA square EC square divided by 4R. So EC square divided by 2R can be written as common, so it will be A1 plus MA square by 2. So it can be written as PC. So this equation will be PT equals to PC into 1 plus m square divided by 2. So this is equation number suppose 3. So this is the total power in amplitude modulated wave in terms of carrier and modulation index. Now we will relate this total power in terms of sideband frequencies, sideband power. So this is equation number 3. Now if I relate this sideband power with this total power, so it can be written as PSB divided by PT. So PSB can be written as m square EC square by 4R, and this can be written as PC into 1 plus m square by 2. Now if I written this term in term of PC, so this is the PC EC square by 2R, so it can be written as PC into m square by 2. So it will, so this PC will be cancelled out. So PSB divided by PT is given by m square by root by 2 1 plus m square by 2. This is the equation number 3. So this equation gives the relation between total power and carrier power, and this equation gives the relation between sideband power to total power. Now if I want to express this relation in terms of current, carrier current and total current in this amplitude modulated wave, then what will be the relation? We know that the power is proportional to I square. Okay, so this is proportional to I square. So PT can be written as IT whole square proportional to IT whole square, and PC can be written as carrier current whole square. So using this concept, we can write this equation number 3 as, so PT divided by PC can be written as 1 plus m square by 2, then it will be written as IT divided by IC whole square equals to 1 plus m square by 2. So it can be written as IT by IC can be 1 plus m square by 2, and this is root. This is the equation number 4. So this one and this one give the complete mathematical soluble equation. By using this equation, you can solve various problems related to power in amplitude modulation. Okay, so now we will solve some problem related to this amplitude modulation. Now problem number 1. Problem number 1, suppose a amplitude modulated wave, total power is given by 1800 watt. If modulation index, if MA is equals to 40%, then what is the value of PC? That means the power in carrier. So here you can solve this problem easily by equation PT is equals to PC 1 plus MA square divided by 2. Using this equation you can solve this problem easily. This is 1800. This is PC, you have to calculate it. Then this is 40%, so 40% can be written as 0.4. okay, so it is 0.1614, and this is the whole square. So 1800 equals to PC into, this is 1 and this is 2.16 divided by 2, this is multiplied. So you calculate as 2 point this is 1.08. okay, 1.08. so 1800 equals to PC into, this is 108 divided by 100. So PC is given by 800 into 100 divided by 108 watt. If you calculate this value, then you will get the total carrier power of this problem. Now problem number 2. Suppose you have a transmitter. The power of this transmitter is given by 9 kilowatt. Okay. Then modulation index, if this wave, the wave from this transmitter is modulated and the modulation index is given by 40%, then what will be the power of the amplitude modulated wave? Then what will be the power of amplitude modulated wave? Okay, so here a transmitter, this transmitter can radiate up to 9 kilowatt, and this wave can be modulated as 40% with modulation index of 40%. Then what will be the power of amplitude modulated wave? Total power. Okay, this is total power. So here this transmitter, so this is carrier actually, so carrier power is 9 kilowatt and modulation index, suppose MA is given by 40%, that means 0.4. okay, so you have to calculate PT. So PT is given by PC into 1 plus MA square divided by 2. So here it will be this is 9 kilowatt, that means 3 into 1 plus, this is 0.16 by 2. So here is 9 into 10 to the power 3 into, this will be 2.16 by 2. So here it will be 9 into 10 to the power 3 into this is 1.08. If you multiply this, so it will be this watt, you can write as 9.72 kilowatt. Okay, this is the problem number 2. You can solve this problem in this way. Now you have another problem similar to problem number 2. Suppose you have a transmitter, problem number 3. So you have a transmitter, the current of this transmitter is given by 8 ampere. Okay, now using this wave you can modulate this wave, and the amplitude modulated modulated wave have current is 8.96 ampere. Now you have to find out what is the modulation index. What is the modulation index in this case? So how to solve this equation problem? Here this is transmitter, so it is the carrier current 8 ampere, and this is the amplitude modulated wave current. That means total current IT is given by 8.96 ampere. So you have to find out what is the MA equals to. So we know that PT by PC is equals to 1 plus MA square divided by 2. So this can be written as IT square divided by IC square equals to 1 plus MA square by 2, because P is proportional to I. So here this is IT and IC. So value of IT is 8.96 and value of IC is given by 8, and this is the whole square is equals to 1 plus MS square divided by 2. Now if you divided this, so it will be 1 plus 1 2 whole square equals to 1 plus MS square by 2. So if you calculate this value, so it will be 1.254 is equals to this. Okay, if you calculate this 1.12 into 1.12, so it will be 1.254. So this can be written as, this is 0.254 multiplied by 2 equals to MA. So this here will be minus, so 0.254 multiplied by 2. So here it will be 0.508 equals to MS square. So or MA is equals to root 0.508. So it will be 0.71. In terms of percentage, it will be 71%. So in this case, the modulation index of this modulated condition, it will be 0.71 or 71%. So in this way you can solve the problem related to amplitude modulation.